going to start looking at logarithms, and so we're going to start with looking at how to convert between logarithmic and exponential form. So we're going to start with some examples. And so the first example, if we're given the logarithm, log of 100,000 equals 5. And we want to convert this into exponential form. So on the left side here, this is going to be log form. And on the right side here, we're going to have exponential form. So to convert this into exponential form, we want to remember that a logarithm with no base written in has an unwritten base of 10, and we're going to create our map. So we're going to say 10 to the 5th power is equal to 100,000. And so we can say now that 10 to the 5th power equals 100,000. Example 2, if we have log base 2 of 1/8 equals -3, and we want to convert this into exponential form, we're going to say 2 to the power of -3 equals 1/8. So 2 to the power of -3 equals 1/8. Example 3, log base 5 of s equals r, and we're going to convert this into exponential form. So 5 to the r power equals s. So 5 to the r power equals s. Next, we're going to talk about how to evaluate logarithms. So we're going to start with some examples again. So the first example, if we have log of 1,000 and we want to evaluate this, we're going to say, okay, well, we're going to say that this equals our unknown of x. And then remember that a log with no base has an unwritten base of 10. And so now we want to convert this to exponential form. So 10 to the power of x equals 1,000. So 10 to the power of x equals 1,000. So now we're going to take a look here at 1,000, because we can write 1,000 as being equal to 10 cubed. So we're going to rewrite our equation to be 10 to the x equals 10 cubed. And now that our bases are the same, so we have 10 and 10, we can ignore the bases, because if we have 10 to some power equals 10 to the 3rd power, that some power needs to be 3, and we're going to say x equals 3, and that's our final answer. Example 2. So if we have log base 2 of 32 equals, I'm just going to start with log base 2 of 32, but we want to say that it equals x, because we need to solve for the unknown of it. And so we're going to convert this to exponential form. And so we get 2 to the x power equals 32. 32 here can be written as 2 to the 5th power. So we're going to rewrite this to be 2 to the x equals 2 to the 5th. And now that our bases here are both 2's, we can ignore the bases and say that x equals 5. And that's our final answer. Example 3. If we have log of 1/10 equals, we're going to write equals in different color just because it's not part of the original problem. So equals x. And then we want to remember there's an unwritten base of 10 if there's no base written. Convert to exponential form. And so we get 10 to the x equals 1 over 10. 1 over 10 here. We can rewrite to be 10 to the negative 1 power. So we can rewrite our whole equation to be 10 to the x equals 10 to the negative 1. Our bases are the same now, so we can ignore them. And we can say that x equals negative 1. Example 4, log base 16 of 4. We want to say that it equals x because it equals an unknown. Convert this to exponential form. So we get 16 to the x power equals 4. Forgot to highlight our last answer. And so now we're going to look here at the 16 because we can change 16 to be 4 to a power. And so the 16 here is equal to 4 squared. And so we're going to rewrite this to be 4 squared to the x power equals 4. And so now remember from your exponent properties that when you have a power raised to a power like this, you multiply them together, so this becomes 4 to the 2x equals 4. And then also remember that if there's no exponent written in, it's an unwritten exponent of 1. And so now that we have the same base here, we ignore the bases. And so we're going to say 2x equals 1. And we have to solve for x here a little bit further than before. So now we're going to divide each side by 2. And so we get x is equal to 1/2 as our final answer. Okay, so now let's look at some properties of logarithms. And so the first property we're going to write down is log base a of 1 equals 0. And so that means that for whatever number the base is, if your argument inside of the logarithm, this is your argument right here, what's inside of the logarithm, it's going to equal 0 when this is 1, when the argument is 1. And so we can write this down as saying this is because if we convert this to exponential form, so because we would get a to the 0 equals 1, and if you remember from your exponent properties, anything to the 0 power is 1. The second property we're going to write down is log base a of a equals 1. And so whenever the base of your logarithm, so this is your base, matches the argument of your logarithm, this is the argument, then your answer will be 1. And so we can write down that this is because if we convert it to exponential form, so because a to the first power equals a, and so anything to the first power equals itself. The third property, log base a of a to the x equals x. So whenever your base of your logarithm here matches the base of the argument here, your answer is the exponent of the argument there. And so we can show that this is true because if we convert this to exponential form, so because a to the x would equal a to the x, and that's equal to itself, so that's true. Example 4, a to the log base a of x equals x. So whenever the base of your exponent equals the base of the logarithm in the exponent, your answer is the argument of that logarithm, x. And so we can prove that this is true by converting this into logarithmic form. And so we're going to say because log base a of x is equal to log base a of x, so it's going to be log base a, that's coming from this base of a, of x coming from this x, is equal to the exponent log base a of x, and so it equals itself, and that is true. And so now we have all of these properties, but we want to remember that all of these properties can also hold true for natural logarithms, so we're going to look at what they would look like for natural logarithms. Okay, so the natural logarithm here, your property would say the natural log of 1 is equal to 0, and so that's ln 1 equals 0. This one would look like the natural log of e equals 1. This one would look like the natural log of e to the x equals x. And then this one would be e to the natural log of x equals x. And so I want you to remember that the base of a natural logarithm is the number e, and the number e is approximately 2.718, but it goes on forever and never repeats. All right, so let's do some examples. And so the first example, if we have log base 5 of 1, well, that's going to equal 0, because if we come back up to the first property, when it's a log with a base of 1, it always equals 0. And we can prove that this is true, because if we were to convert this, we would get 5 to the 0 equals 1, and that's true. If you want to write down, this is using property 1. Number 2, if we have log base 5 of 5 to the 8th power, and so we want to remember when the base of the logarithm matches the base of the argument, your answer is going to be your exponent. And so this will equal 8. And so that right there goes right here to number 3. And so we can prove that this is true if we convert this to exponential form. We'd get 5 to the 8th power equals 5 to the 8th power. And then you can write down, if you'd like to, that this is using property number 3. Example 3, if I have log base 5 of 5, now we want to remember that when the base of the logarithm matches the argument of the logarithm, the answer is 1. And we can prove that true if we convert to exponential form. We'd get 5 to the first power equals 5, which is true. And that is up there using property number 2. And then example 4, if we have 5 to the log base 5 of 12, now we want to remember when the base of the exponent matches the base of the logarithm in the exponent, then the answer is the argument of that logarithm. And so this would equal 12, and we can convert this to logarithmic form to prove it true. So it's going to be log base 5 of 12 equals our exponent. So log base 5 coming from right here of 12 coming from this 12 right here equals our exponent. And that's true because they're the same. And this right here was using our last property, property 4. And then just some reminders for you, so you want to make sure that you remember these. You have a common logarithm, which we talked about earlier, and your common logarithm is if you have log of x, that's equal to log base 10 of x. And then you have your natural logarithm, which we also talked about earlier. Where you have the natural log of x is equal to log base e of x. And then remember that e is a number that is equal to approximately 2.718, and that continues on forever.